or new functions if you want. What was the first one that we discussed last time? The entire time. The new lesson from last time. What was it on? Can anyone tell us what we studied last time? Anyone, please? Anyone? What was the main concept last time? Nobody remembers what we studied last time? I refuse to believe that. What did we study? Anyone, please?
Was it the 6 basic functions?
Yes. We studied transformations on the basic functions to create new functions. So that was one method. We're going to look now at other methods. So the first method, one more time, let's write it. So the first method was transformations. By reflections and shifts and stretches and shrinking, we determine new functions. Here's the next one that we are going to talk about right now. Addition. What do I mean by addition? So if I add a function to another function, I create a totally new one. Here's the third one. Subtraction. F of x and g of x. Can you guess number 4? Can you guess number 4?
Multiplication?
Of course. Can you guess number 5? You may not be able to guess number 6 yet because I'll explain it, but number 5 you can.
Division.
Of course. There is a problem with division. So I have to say if, which I didn't have to say here. But with division, I may run into a difficulty. And what is it? If
x equals 0.
You mean if g of x does not equal 0. Correct. That's it. Good. Number 6. Number 6 is totally new. It's called function composition. We'll go through all these and then we'll talk about number 6. So we know transformations again. Applying transformations on basic functions, we can create new functions. Now let's talk about these 4. Addition, subtraction, multiplication, and division. These have a common characteristic. And the common characteristic here is the domain of the sum, difference, and product is always the common domain. I'll explain in a minute. Okay, so let me give you an example. So let's say I start with f of x. Let's say f of x is very simple, 2x plus 3. And let me say that g of x equals 3x minus 4. Very simple situation. So can I, from here, can I create a function which is the sum? This is the name. So when you see f plus g in parentheses of x, this actually means this function, the sum. So f of x plus g of x. I have 2 functions, and I want to create their sum. Fine. So I write f. I didn't mean to write that. I'm going to erase it. I meant to write this. F plus g of x equals. I copy f of x, and I copy g of x. I combine like terms. I get, can anyone tell us how we get what we get when we combine like terms? Can anyone give us the final form of this function, which is the sum? It's called the sum of the
5x
minus 1. Perfect, excellent. So this is indeed 5x minus 1. And this is the sum, the function called the sum of these two. Good. Number 4. Now, number 2, if I want to determine the difference, how do I read this? F minus g of x. Of course, this will be f of x minus g of x. But now I have to be careful because I copy f, but I have to keep in mind that I have to distribute to all terms the negative sign. What should I write when I distribute the negative sign to 3x minus 4? Can anyone tell us what to write when I distribute negative 1 to 3x minus 4?
Negative 3x plus 4.
Very good. Now we combine like terms, and we get negative x plus 7. What is this? This is the function called difference. So when we have two functions and we want to create its difference, the difference of those two functions, I can create a g minus f if I want to, or f minus g, doesn't matter. I get a new function. I will not get the same function if it's g minus f, but I get a new function. And number 3, let's say the product. This is the way we write it. So this is the product. Fg of x, of course, this is f of x times g of x. So I will be writing side by side 2x plus 3 times 3x minus 4. And I distribute 2x to 3x, 6x squared, 2x to negative 4, 3 to 3x, and 3 to negative 4. And I combine like terms. This is 6x squared, and this is 9 apples minus 8 apples, so it's positive x and minus 12. What is this? It's a totally new function. So from two given functions, I multiply them to get a new function, which is the product of those two. Now, notice that. Can anyone tell us what is the domain of these functions? Both of them have the same domain. Can anyone tell us what is the domain? What x can be? What are the values of x that work here, are acceptable here? Can anyone tell us what x values are acceptable here? Which means what is the domain of the function? What do you think? Christy, what do you think? It's okay if you're wrong. Just let's move on and say something, please. Okay, Christy is not with us. Ayana, what do you think? What will be the domain of f and g? Okay, Ayana is not with us. Anyone else? Anyone else? Brand, what do you think? It's okay if you're wrong.
I always get these wrong. I'm trying to figure this stuff out. I don't know. Yeah, it's always negative infinity or something like that. Infinity. So I'm at that stage.
Yes,
so I don't
exactly.
know.
It's all real numbers.
Okay.
It's all real numbers. You can replace x by anything. This is not a function with problems. It's a linear function. We can plug in anything we want. There is no restriction whatsoever. It's not a ratio. It's not the square root. It's just a polynomial function. It's a linear function. Anything works. So notice now that the common domain of these two is also negative infinity to infinity. And you see that it works for 5x minus 1. It's the same domain. It works for negative x plus 7. The same domain. No restrictions, no problems. And it's always the same thing for any polynomial. It's the same thing for the product. However, so we call this domain common domain to both f of x and g of x. What is it in this case? Negative infinity to infinity. The same domain will be the domain of the sum, will be the same domain of the difference, and will always be the same domain of the product. This is always true. This is a law. Once we have the domain of f and we have the domain of g, we will determine the common domain. In this case, it was too simple. It was the same. The sum, difference, and product will have the same domain. Will the ratio have the same domain? I don't know. We are going to determine the ratio right now. So here's the ratio. So for f over g of x, f over g of x. Obviously, this is f of x over g of x. I'm copying f of x as 2x plus 3, and I'm copying g of x as 3x minus 4. Do you think that this function will have the same domain as the common domain or not? What will you say? What would be the domain of f over g? Anyone, please? What is the domain of f over g? Or what could be the problem here? Do you see any potential problem? Please talk to me, please. Katie, do you want to try? Is there any potential problem here? It's okay if you're wrong. It's okay.
Yes.
Good. What could be the problem?
I'm not really sure.
If you remember, we said that division by 0 is undefined. So 3x minus 4 cannot be 0. We had situations in which we determined the domain in the past. So I move 4 and divide by 3. So x cannot be 4/3. If x is 4/3, the fraction is undefined. So anyone remembers how we write the domain? By excluding, in interval notation, by excluding 4/3. Shay, would you like to answer this? How do we present the domain in interval notation by excluding 4/3? Christy, are you back? You want to try?
Is that where you like put the U in the middle?
Exactly. Excellent. Yes, indeed. Yes. Perfect. How do I write it?
Wait, what was your question? I'm sorry.
You're correct, but how do I write the domain? I have to exclude from the entire domain, I have to exclude 4/3. How do I do that? How do I write? You're correct. I have to use the union. Correct. Anyone would like to try? So negative infinity 4/3 and 4/3 to infinity. So anything but. So as you notice, the sum, difference, and product, they always are very easy because they always have the common domain of the two functions f and g. But the ratio may or may not. I'm not saying that this will always happen. I'm saying the denominator cannot be 0. Therefore, from the common domain, I have to exclude 4/3. Division by 0 is undefined, is not acceptable. Okay, now let's talk about, maybe we should look at another example. Would you like to choose another example? Do you need me to choose another example? Please say yes or no.
Can you choose?
Yes, I will. So let's look at, let's say 59. I'm copying from page 312, and we have f of x equals 4 minus x, and g of x equals 2x squared plus x plus 5. So we're going to look at all 5 possibilities, although I haven't mentioned the 5th one just yet, but we're going to look at all of them. So we selected 2 functions, and we're going to determine the sum, the difference, the product, the ratio, and also something called function composition. I'll get to it when we finish the first 4. Now, can anyone give us the domain of f? Because we need to find the common domain from the beginning. Can anyone give us a domain of g? What is the domain of f? Please. These are polynomial functions. The domain is always all real numbers. Linear, quadratic, cubic. Good. So then the common domain is also the same thing. The domain of the sum, the domain of the difference, and the domain of the product will always be the same with the common domain. The ratio may or may not. We don't know. Okay. So the sum, f plus g of x equals f of x plus g of x. I write 4 minus x plus 2x squared plus x plus 5, and now I just combine. 2x squared, the x with an x go away, and then plus 9. What is this? The sum is a new function that was determined by creating the sum of the first of the given functions. Okay, now the difference. Carefully, I write the formula, which is f of x minus g of x, and then I copy 4 minus x, but now I have to distribute the negative sign or negative 1 to all these. Negative 2x squared minus x and minus 5. I combine like terms. I write the first as being, because it's the degree, so I have to start with the highest power. The negative x with minus x is negative 2x. And 4 minus 5 is negative 1. What is this? A totally new function. From the given functions, I subtract them, f minus g, and I got a new function. Okay, the next one is the product. I write the formula first. I write them side by side. 2x squared plus x plus 5. And now I multiply. 4 distributed to these 3 terms. Negative x distributed to these 3 terms. 8x squared plus 4x plus 20 minus 2x cubed minus x squared minus 5x. Stop me if there is any question. Let's take a moment and see if this is clear. Is it clear what I'm doing?
Yes.
Perfect. So 8, 4, 20, negative 2x cubed, negative x squared, and negative 5x. In descending order, negative 2x cubed plus 7x squared, and then I have 4x minus 5x and minus 20. What is this? A totally new function. How was it obtained? Multiplying f by g. Now let's look at the ratio. Last one here. So f over g of x equals, by definition, f of x over g of x, and f is 4 minus x, and g is 2x squared plus x plus 5. 2x squared plus x plus 5 cannot be 0. Okay, so I'm going to use the feature in the calculator, the polynomial feature. We go to apps and then 9 and then polynomial root finder, and yes, this is second degree. Leading coefficient is 2 and middle coefficient is 1, and the free term is 5. So now I want the calculator to, okay, notice that these are imaginary numbers, which means it happens that this is always true. Therefore, it's a lucky case. F over g of x has the same domain with the others, with a common domain. So this was an easier situation. I did not have to remove anything from the domain. Here, x could not have been 4/3 because you would make this function undefined. But here, I checked, this is never 0. The solutions are imaginary. So since this is never 0, this is a lucky case in which the domain is the same with a common domain. I'll be quiet for the next 10 minutes, I promise. And